So hi everyone. Today I'm gonna talk about a few different secrets about app performance. So hopefully you'll learn something new there. My name is Guillaume. Chau. I'm from the Vue.js core team. You can find me everywhere with Guillaume. So let's get started. So the agenda today is seeing techniques to improve the app performance. And this is quite important because better app performance usually means better user experience. And you should mostly strive for better user experience, I think. So let's start right away with the first one, which isn't really a secret because it's part of the DAC. So that's functional components. So let's say we have this nice little component, which is showing one color or another one, depending on the value prop. And let's see how it's performing without using functional components. Oh, maybe I can zoom a little. So on those demos, on the top right corner of the screen, you can see a frame rate counter. So keep an eye on that. So let's go to the first demo. So here I got 800 components, which gonna be created and destroyed every frame. So let's see how it performs. Not too bad, 12 frames per second. Okay. So each time I'm gonna display some kind of profiler statistics from Chrome. So here we have a pie chart. So the yellow part is scripting, so JavaScript and DOM manipulation. And the purple part is rendering, green part is painting. So we can see here that we spend a lot of time in scripting, and the browser doesn't have a lot of time for rendering actual content. So let's see how we can optimize this. We can just turn this component into a functional one by just using this functional attribute in the template, and then using the props instead of directly accessing it, because a functional component doesn't have local state, so it doesn't have this. So that's why it's faster to create. So let's see how it's performing. Ooh. Faster, 2 times faster. Nice. So if we go again to the profiler, we can see we spend less time creating the components in JavaScript. So the browser has more time to actually render the frames, so we get better frame rate. So the second secret is called child component splitting. So let's say we have this component and it has a part there which is heavy to render, and we're gonna see how it performing in the demo. So I got I think 100 components with this template. Okay. So we got 16, 17 frames per second. Not too shabby. So again, we spend a lot of time in scripting because we have a heavy part in the template, which is doing a lot of stuff. So here I'm simulating it with a heavy method. So we can simply optimize this by splitting this part and put it into a child component like this. So we put the heavy part into a child component. So note that this only works if the child component doesn't depend on the data that makes the parent component re-render, or not as often. Otherwise, it will still re-update. So how does this work? It's because Vue will automatically skip re-rendering children components if the data dependencies didn't change. So that will like improve performance quite a lot actually. Ooh. Just by making this little change. So if we go back to the profiler, we can see that there is a huge improvement in like the time spent in rendering instead of JavaScript. So you can see like it's almost 2 times less time spent in JavaScript. Okay, great. Third secret. So this one is called local variables. So let's take a look at this component here, which is like computing a few like computed properties here. So we got this computed property using another computed property. So this one is actually very dumb. It's like just returning a number, but it's actually proving the point because we're gonna like call this computed property in a loop while like computing the other one, and it's gonna cause some performance issues. So if we take a look again at the demo, we get like, oh, less than 10 frames per second. So not very, very good. So to optimize this, so if we could look at the provider, sorry, yeah, we can see that we spend way too much time in JavaScript and the browser is like, oh my god, I can't render everything. So let's optimize this by just using a local variable inside the computation. So instead of accessing the computed property directly every time we want to access it, we just like cache the value in a local variable at the start of the computed property, and then we use this like standard JavaScript variable. So let's see if it makes a difference. Yeah, 13. So why? Why do we spend like a lot less time in JavaScript? It's because each time you access a reactive state in Vue, it will like run a little bit of logic in the getters to know, oh, this data has been accessed. So if it changes, I need to re-render the thing. So this little bit of logic, if you like run it a lot of times, it can like have performance impacts. Fourth one, we use them with Vue. So let's take a look at this template, and we say that we're gonna display some heavy templates in there, and we're gonna use the if and the else to like toggle state the templates. So let's see how it performs. Oh, very bad. 8 frames per second. So in the profiler, again, I think you can start seeing a trend here, because when you have most of the time spent in JavaScript, it mostly results in bad performance. So let's optimize this, and instead of using the if and the else, we're gonna use Chau. And this is gonna reuse the DOM and reuse the components. So both Vue and the DOM in the browser have less work to do, because everything is just there, and Chau we just like put display on the elements. So let's see how it's like this simple change affect things. Yeah, way better. So again, if we looked at the profiler, we can see we spend less time in JavaScript, so more time for rendering, so better frame rates. Please note that this may also impact memory, because since you're like keeping more stuff alive, well, memory will be like more used. So keep that in mind. The next one is pretty similar. It's called Keep Alive, because that's the name of the special component. So let's take a look at this simple app with a Vue view. So this one is Keep Alive is really helpful when using Vue router, sorry. So let's go to the demo. This one is quite different, because we have a simple page and a heavy page. So when I'm gonna switch to the heavy page, you're gonna like freeze for 1 or 2 seconds. So here's the heavy page again. I click, oh, yeah. So the app freezes for like 2 seconds. So how to like get around a little bit around that. So yeah, we can see that we are blocking the browser for a few seconds, so it's not very good. To get around that, in some ways, we can just wrap the router view with keep alive, which is a special component in Vue. And this component will keep the different pages in memory instead of destroying everything each time you switch to a different route. So let's see how it affects the app. So I'm gonna enable this. And when I go to, the first time I go to the heavy page, it will like be not different because we still have to render this big component. But if I go back to the other page and switch back to the heavy page, it's instant because keep alive cached the whole thing and nothing was destroyed, so the browser has less work to do. So, yeah, there's a pretty big difference here. Again, it's more memory intensive because the pages are not destroyed, but you can mitigate that with a few attributes on keep alive. For example, you can like include or exclude some components from being cached, or you can use the max attribute to limit the number of cached routes. So it's very nice. The next one is called Deferred features. So let's take a look at this heavy page. So we have a title, but then we are displaying a lot of content, which may like take some time to render in the browser. Sorry. So again, basically it will be like the same demo as before with a simple page and a heavy page. And if I switch to the heavy page again, the app is like frozen for 2 seconds. So not a very good user experience. So yeah, blocking the browser for like 1 or 2 seconds. So to get around that, what you can do is to render progressively your component instead of rendering everything at the same time. You can just conditionally render parts of your page or your component depending on the number of frames has passed since it was created. So here I'm using a deferred mixin. I will show it to you just on the next slide. But basically, we are like deferring this part to the second frame and then this part to the third frame. So let's see what it's gonna look like. So as soon as I switch to the heavy page, the router the browser is able to instantly render the new page, but only the beginning, and then like the heavy parts are deferred to other frames, so the browser can like progressively render the component. So again, if I switch, it's like instantly switching the routes, but then like continuing rendering stuff. So the user experience is improved a lot, but actually the performance is not. So it takes the same time to render everything, but the perceived performance is like nothing compared of, like nothing similar to what we had previously. So this is also important. So you must keep in mind that like perceived performance is as important as like actual performance in the browser. So I can like show you the demo again. So if it's unoptimized, if I switch to the page, oh, it takes 2 seconds to like react to the click. And if instead I'm just deferring stuff, the perceived performance is way better because when I click on the button, it's instantly like switching to the new route. So let's see how I did that with this defer mixing. So I'm using like a counter data property, and when the component is mounted, I'm gonna like increment this variable for each frame. So after the component is mounted. And then you can use this method in the template to like conditionally run the part of the template using the if, and it's like gonna just compare the number. So that's it for this one. Next one is like almost the same concept. It's time slicing, but for data. So imagine we are going to like commit thousands and thousands of items into a React store. It happened. I was on a project where we had to do something like this, which was crazy. But yeah, it can happen. And I'm gonna switch to the last part of the demo. So I've put an animation which is created with JavaScript, so we can see when the app is freezing or not. And I'm gonna generate 10,000 items using Figure, which is a nice library to create like random data. And when I'm gonna commit those into the Vue store, you'll see that the animation is like frozen for a few seconds. That's not a very good user experience because again, the app is frozen, it's not responsive. So let's mitigate that. Yeah, again, interaction broken. So let's mitigate that by splitting the array of items into smaller chunks and then committing those chunks incrementally over time. So you can like, for example, split the items array into chunks of 1,000 items instead of like committing everything at the same time. And on the next frames, you commit the next 1,000 items. So let's see how it goes. Yeah. Enabling time slicing, and then when I commit, you can see that the browser still has some change to re-render the app. So the app is not entirely frozen. It's like not performing well, but it's better to like than like freezing. So I'll show you again. So the app is still responsive kind of, but yeah, the performance is not great. But it's better. For example, if you want to display a loading animation when you're like committing the items in the Vue store, and you don't do this, well, did you see the loading animation? No, because the browser was frozen basically. So if you're using this technique, you give a chance to the browser to actually re-render the app so it can display the loading animation. You can also see that if you like splitting the items, the items array into smaller chunks, the performance will be better. So it's like smoother, but the whole operation will take more time. So you have to like balance this depending on the user case. So let's see how it goes. Yeah. So you can see here that we give a few frames to the browser back so you can like re-render stuff. So for example, displaying the loading animation. And if we like do smaller chunks, you can see that the frame rate is way better, but the whole duration is longer. So you have to like balance that. The eighth performance secret is about making data non-reactive. So let's again have a very huge array of items displayed, well, not displayed, but committed to a Vue store. And this item property here is a big object generated by Faker with like tons of attributes like company information and stuff like that. So it's gonna take some time for Vue to actually walk to the data and make everything reactive. So again, if I like try to commit 10,000 of those items into the Vue store, the app will like be frozen for a few seconds. But we can optimize this by not making those data reactive, because we know in the application that we will not like expect them to be reactive, and we will not like automatically update the user interface if they changes. So there's several ways to do this, but I'm actually liking this way. You may have heard of object freeze, but the downside is that it's gonna actually freeze everything. So basically everything will be read-only. So you don't have like, you can't change them later. But in the actual projects I worked on, I needed this. We sometimes still had to like change some data. So we couldn't use object freeze. And instead I'm using object defined property here, which is an API that allows you to like add new attributes to an object. And we are using this option, which is configurable, and we set it to false. And this is gonna tell Vue.js to not make this attribute and its content reactive. So you can then still change the values inside, and sometimes maybe you want like to update something, but it's like not very common. You can still change the value and then tell you to render, for example, using another reactive value, data. But this is gonna have a huge impact on this demo. So if I'm toggling this and I commit, yeah, like, oh, did you see it freeze? Almost, yeah. So the performance difference is like, can be very, very huge. Here we have like a 17 times faster app. The last one is virtual scrolling. So we have this like big array of items, and we want to like display this. So you may want to like use functional components because they are like faster to create, and use V4 to like display the list. So I'm gonna regenerate the items, only 1,000 of them for now. Come on. Yeah. So I'm gonna commit them and then display the lists. Oh, it's a bit laggy when I created the list still. So if I like toggle the list, yeah, there's a little bit of lag. So we can improve this lag here by using virtual scrolling, or sometimes it's called windowing solution. So I'm using my library called Vue Virtual Scroller, and I'm using this component, which is recycle scroller, which is gonna do the same V4, but instead of displaying everything at the same time, it will only render the visible items. And actually, one of the benefits is you can use normal components, and yeah, you don't have to like to be forced into functional components, because, well, only a few of them will be displayed at any point of time. So the performance will no longer be like tied to the number of items. So let's take a look at this recycle scroller. So it's like very similar, but when I switch the list, it's like instant. Nothing, no lag. Okay, maybe that's not that impressive, but when you have 10,000 items, that's when like things start to change, because, well, V4 crashed. So it crashed the whole computer. So I'm not gonna like demo it. Gonna generate 10,000 items still. I'm gonna switch to unoptimized and commit those 10,000 items, and I put this message. So if you open the demos, it won't crash your computer, hopefully. But if I use the recycle scroller, like instant, boom, 10,000 items. I can like scroll through them. So basically, it's like displaying only the like 30 or so items visible on the screen. So basically, you can like throw at it any amount of data you want, will be like still be performant. Like this, very nice frame rates. So that's it for the 9 performance secrets. You can like learn more about virtual scrolling by going to this link, Vue on my GitHub at the Vue Virtual Scroller. And you can check out all the demos at this other repository, so Vue 9perf secrets. And you can support my open source work, so this and Vue DevTools and VueCLI and other stuff you may use or not on my Patreon page. And a big shout out to my amazing sponsors. So we got Vue School and Vue Mastery, which are amazing learning resources about Vue, and Vuetify, which is, as Chris said, a very nice material component library, and Frontend Developer Love, which are the amazing organizer of Vue Amsterdam conference in Europe. So a big shout out to them, and please check them out, and please check my Patreon out as well. So thank you a lot. I hope you learned some stuff.